Notes 1, which is all about acids and bases. So read chapter 19, chapters 1 and 3. Acids taste sour. We didn't taste them in the lab. Bases taste bitter. We did not taste them. Feel like it burns. Feel like it burns. And bases tend to feel slippery. Litmus turns red, and turns blue in base. Okay, it stays no change in neutral. Phenolphthalein is clear and in base. Conductivity, yes, and conductivity. Alright, so all things can conduct electricity, acid, base, or neutral. It's all about the ions. pH less than 7, or for bases greater than 7. Right, and neutral is 7. Add a metal, you get reaction, but bases get no reaction. Alright, so we can tell different substances based on their properties. So you have to get to know what kind of properties each kind of substance has. So what's vinegar? Well, we tested it in the lab and we know it's acid. Ammonia we tested in the lab and had properties of bases. Cleaning supplies can be either. OJ is an acid, orange juice, and gastric juices are acid as well. Okay, so some common things. What are they? Acids and bases, and you can tell them apart by testing their properties. So, what do chemists think acids are? Well, one way to remember is that acids are really friendly. They start with H, and that H is telling you, hello, I'm an acid. So here's a definition of Arrhenius. Acids have H plus and bases have OH minus. Here's another definition, Bronsted-Lowry definition. Acid is an H plus giver, and bases are H plus takers. So what does that mean? Well, acids donate protons, and an H plus is a proton. Bases accept a proton, and an H plus is a proton. So they do the opposite things. So here we have two substances, H2SO4 and AlOH3. Hello, this is an acid. Oh yeah, I'm a base. So what do? They react to form water and a salt from the ions that are left over after the acid, the H plus from the acid and the OH minus from the base make water. So to balance this equation, we're going to need a little more aluminum. We're going to need some more sulfates, which is going to give us 6 waters. Right? This is a base. How do I know? Oh yeah, hello, acid. Right? So then, they're going to make water because you have your OH minus and your H plus, which is H2O, H2O. All right? And then you're going to get NaCl to finish that one up. All right. Every acid has a conjugate base, and every base has a conjugate acid. What? Well, let's look what's going on here. If I look from this side to this side, I see that this compound turns into this ion. How is that? Gives away H plus. So this must be an acid. Okay. That means this is the conjugate base of that acid. Okay. Look what happens from here to here. This takes H plus. So this must be a base, and this is its conjugate acid. All right. I want you to see if you can try to find those in this problem. So copy this into your notes. See if you can decide what the acid base on the left are, and then the conjugate acid and the conjugate base on the right are. All right. So you do it. You do. Okay. All right. So H plus and H3O plus. You run into this a lot in chemistry with acids and bases. What are these things? Well, they're actually the same thing. So what is H2O? H2O is water, right? And then if it's got another H on it, it turns into H3O plus. So this H plus from acids doesn't really hang out as H plus. It always attaches to water. Always attaches to water. So you don't ever really have H plus. You always have H plus on a water molecule. So this comes from this plus water. All right. Strong acids. Whoa, here we go. What does it mean to be strong? Well, it means that the spontaneous reaction is of the compound breaking up into its ions. It goes forward only one direction, forward only 100%. So strong things break up 100% into their ions. They spontaneously go forward. So there's 6 compounds that do this all the time. One of those is hydrochloric acid. So you should write down the names and the symbols of these acids. Hydroiodic acid, hydroiodic acid. Right. Sulfuric acid. What makes sulfuric acid strong? Well, it ionizes completely into its 2 ion parts. This is hydrobromic acid. Right. It ionizes completely. What makes this strong? This is perchloric acid. Well, what makes it strong is it ionizes completely. And this is nitric acid. So how many strong acids are there that you have to know? 6 of them. Memorize 6 of them. And what does strong mean? It means they break apart totally. They go forward in the forward direction to make ions. Okay, what about strong bases? Same thing. They ionize completely. They go forward in the forward direction only, spontaneously, to make ions. All day and all night ions. So where do the strong bases come from? Well, remember, hydroxide makes it a base. So there are hydroxides of group 1 and group 2 on the periodic table. Group 1 and group 2 hydroxides. So this is group 1, sodium, with hydroxide, and then it breaks up totally into sodium ions and hydroxide ions. Alright, so let's look at this. HNO2. Hello, I'm an acid. But wait, it is not one of the 6 strong ones, so this is a weak acid. How do I know? Well, I know it's an acid because it starts with H, and I know it's not one of the 6, so it must be weak. We'll talk about what weak means in a second. Okay. Oh, yeah, I'm a base. Oh, yeah. So then I see, let's see, calcium's right there. So this is a strong base. HCl. Let's see. Hello, I'm an acid. Hello, here you are. Hi, I'm an acid. So then we look on our sheet, our notes that we just took, and we found out it's a strong acid. Hey, wait a second. This doesn't have an H plus or an OH minus. This is ammonia. Please memorize ammonia is a base. Ammonia is a base, and it must be a weak base because it's not coming from those hydroxides. Okay. What if an acid or base is not strong? So we're finally talking about what makes it weak. All right, so it starts with the H. That makes it an acid, but it's not one of those 6 on the list. It must be a weak acid. What weak acids do is equilibrium. Yay, equilibrium. Equilibrium. Equal rate forward, equal rate as reverse. So it don't ionize completely, but usually stay together as a whole molecule. And reactants are favored at equilibrium. But some products do form, or else it wouldn't be an acid. Okay, so this is an equilibrium reaction, meaning some of these break into ions, some of those turn back into whole molecules. What do most of them do? Stay together. Okay, not many ions. Not many ions. Equilibrium. Okay, what about bases? Well, ends with OH, base. But it's not group 1 or 2, so it must be a weak base. And ammonia. And ammonia. Alright, so it does not ionize completely. It usually stays together as whole molecules. Alright, concentration does not mean strength. Concentration, we really got to think about molarity. Concentration is molarity. Molarity is concentration. Strength is how much it separates. That's the ionizing we just talked about. Concentration is how packed together you are, so that's molarity. All right, so we'll say 1 molar or greater is concentrated. And then write this down. Less than 1 molar is dilute. Okay, so now we have another list here. I'm going to do 2 of them with you and then right now, and then we'll do the rest in class. Okay, so I look at this whole thing. I say to myself, hello, acid. Yay, hello, acid. All right, now it's strong. How do I know? One of the 6. And it's dilute. How do I know? Because the molarity is less than 1 molar. So it's a dilute strong acid. All right, I'm going to do another one. I'm going to pick this one. Okay. Oh, yeah, base. Base. Oh, yeah. Oh, yeah. Okay, so it's a base. And then it's strong. How do I know it's strong? Group 1 hydroxide. Alright, so if I go back and I'm like, oh look, there's sodium with hydroxide. Right? And then it is concentrated because it's greater than 1 mole. Alright, so that's a concentrated strong base. Alright, we're going to do the rest of them in class. Indicators. What do indicators indicate? They tell us what the pH of something is, and they can tell us if it's an acid or base. So really, litmus is already an acid itself, but it's at equilibrium. Look, equilibrium. Yay. All right. So what indicators do is they shift the equilibrium because of adding or taking away a substance. All right. So Le Chatelier's principle. All right. What if I add some more hydrogen ions? That's an acid. Right? What if I add acid to this? So I add H+. Well, adding H+ stresses this side. So then it shifts away. So it's going to turn red. Litmus turns red in acid. Hydroxide ions. Now hydroxide ions are different. They're OH minus. What do OH minus do? They react with and pull out the hydroxide ion. So then it's going to shift left. Shift right to fill up that hole. Turn blue. So bases turn blue and acids turn red in litmus. Oh, look, it's phenolphthalein, another indicator. But what if we added H+? Acid is added H+. More stress. Shift left. H+, more stress. Shift left. Clear. All right. Base. OH minus removes H+. So there's like coming out. Fills hole. Fills hole. Shifts. Alright, so good. Indicators are equilibrium. Gotta love it. There's a lot of indicators you can use. And all these indicators work by shifting their equilibrium when you have acids or bases. Okay, to review. Hello, I'm an acid. I'm friendly, so I give away my H pluses. Start with hydrogen. Memorize your strong acids. There's 6 of them. And bases. Use the PT for that. Use the PT. Version 1 and 2 hydroxide. Concentration is molarity. It does not mean strength. Strong's means spontaneously makes ions totally. Indicators change color at different pHs and know your properties. All right, please read the book, sections 19.1 and 19.3, and hopefully after a little more practice, we can do all these things. Peace out from home.